So we'll take up another problem, that is we'll try to find out the maximum bending moment at a section of 4 meters in case of multiple point loads. So this is the question. We don't have any figure in this one, only this figure is available here. So the wheel load shown in figure rolls over a beam of span 10 meters. The span of the beam is 10 meters. We have to calculate the maximum bending moment at a section 4 meters from left end. Okay. So for that case, we need to understand what are the loads, average loads on another section and another average load on remaining section. So we need to do a small type of table in this figure, in this problem, since we have multiple point loads here. So we need to draw this table. So the very first thing which will be coming here is load cross this section, average load on AC, average load on BC, and remarks. Okay, what is AB? AB is the beam and C point is the section which is at a distance of 4 meters from left end. So load cross this section is nothing but the very first load which will be crossing the section will be 50 kilonewton. So 50 average load on AC will be, that is on the left side, will be having how many loads? 200, 150, 300 divided by 4. What is this 4 actually? 4 is the span of AC. Similarly, average load on BC will be, what are the loads on the next section? We have only one load, that is 50 by 6. What is this 6? Remaining part of the span of BC. So 50 by. So what is the value you got? We got the value 162.5 here and 8.33. So which is, we can say that AC is greater than CB. So in the next case, we'll go for 300 kilonewton. So after 50 kilonewton, 300 kilonewton will cross the section. So 300 plus 50 will be 350 by 4, and 350 plus divided by 6 is 58.3. So again AC is greater than CB. Now next load which will be crossing the section will be 150. So 200 by 4 is nothing but the load which is on the left side of the section. So 200 by 4 is equal to 150, 500 by 6. So here the sign is changing, the sign convention is changing. AC is greater than CB. In the next case AC is greater than CB, but here at this point AC is less than CB. So here at this point we have to place 150 kilonewton at this point, and we have to calculate all the ordinates accordingly, and then we have to calculate the maximum bending moment at point C. Okay, so how to calculate these ordinates? We all know about these things, that how we have to take down this value first. We have to calculate this value, L minus A by L into A. Then we can go for, if we know this value, from the help of, with the help of similar triangles, we can easily calculate the value of y1, y2 and y3. So after that we can multiply with this, with these values, that is 200 into y1, that is 1.92, then 150 into this value, that is 2.4, then 300 into 2, then plus 50 into 1.52, which will be equal to 1420 kilonewton meter. Okay, so this is how we calculate our maximum bending moment at a section in case of multiple point loads. In the previous case we have seen a maximum bending moment at with the help of UDL, but here in this case we are calculating maximum bending moment with the help when there is multiple point loads are there. Okay.